So hello again, and then we will start with the part 2 of the lecture, which is introduction of ultrasound to tissues. We have 4 types of interactions that the ultrasound can be interact with our body. When the ultrasound travel from the, let's say, the device to our body, it will have 4 interactions. What is these 4 interactions? We name it reflection. Reflection, scattering, refraction, and attenuation. And from here you can see if they are sending ultrasound and the ultrasound return back to you, we name it reflection, which is the most important one, the major interaction that happen can lead us to make the images from the ultrasound. And when you sending ultrasound and the ultrasound is just like going to different direction, like these spikes here, that's mean you will have scattering. Refraction, when you are sending ultrasound and the ultrasound is just like it will be transmit through the body, and then it just changing the direction or the angle, we name it refraction. And the last one, when the ultrasound travel without changing the direction, without go back, without changing the angle, but it will be reducing the energy of the interaction, we name it attenuation. And here, a quick equation, reflection is the occur when the ultrasound wave is deflected toward the transducer. Part of the energy beam will be transmitted across the boundary, while some of them will be reflected. And here it's appear like a part of them will be transmitted, part of them will be scattered, and part of them will be returned back to you. The reflecting beam produced is called an echo. This is particularly important in the ultrasound imaging. So when you are sending the sound and the sound you return back to you is the same as you have in the room alone, and you are talking, then the room contain all of them as well, and you are talking, that means the sound will be returned back to you. It will be hit the wall and return back to you. We name it echo. Okay, and the major factor affecting the amount of reflection is aqueous appendix mismatch. For example, you are sending ultrasound to the wall, how much ultrasound will be returned back to you? If you are sending ultrasound to the tissue, soft tissue or fat or air, what is the amount of the reflection back to you? This is depend on something, we name it aqueous appendix mismatch. The aqueous appendix is the physical properties of a material which decide how easily ultrasound can travel inside the material. Okay, how easily ultrasound can travel through the material. Aqueous abundance is by simple Z. Aqueous abundance is dependent on the density and the acoustic velocity of the material. Okay, so when just like when Z is high, that means the velocity, when the density is high for any material, so the Z will be high. For example, the bone have high Z, while the air have low Z, and so on. And here you can see the different Z that we have. The air have the lowest Z, while the skull bone have the highest Z of the material. What that means? That means the effect of the aqueous appendix in the ultrasonic emission become noticeable at interferences between different types of material. The ability of the sound to transfer from one material type to another material type depends on the difference of the aqueous appendix. What that means? That means if the sound travels from the air to the bone. Okay, so what he said here for you, the ability of the ultrasound to transfer from the material type, for example, air, this is the material type, to another material type, which is bone, it will be depend on the differences between the aqueous appendix of the materials. So what is the difference between them? This one minus what? Minus this one. Okay, what that mean? If the difference is massive, that means if the difference between the skull bone and the air is a massive differences, that means the sound will be reflected. Okay, if the difference is less, that means the sound will be not diffracted or partly not reflected. For example, you have air and bone. Again, the difference between them is high differences. See, there's high differences between them. Okay, when the high difference between them, that means you will lead us to understand that the sound will be highly reflected. While, for example, if you have air, fat, and water, see the sound travel from the fat to the water. See, there is a small difference between them. So the sound will be not reflected, and so on. So the amount of the sound will be reflected depend on the differences between the aqueous appendix. Okay. For example, how much will be ultrasound will be travel? Ultrasound will be reflected from the interferences depend on the aqueous appendix mismatch. The higher the differences, between the materials, it will be higher reflection. Okay, it's if you have a higher differences between Z1 and Z2, let's say this is air, this is bone, that means the highly one will be reflected. If the Z is not big difference between them, the highly will be what? Will be transmitted. The second one is the scattering, and the scattering occur when the width of the orbital dimension of the tissue boundary is less than one wavelength. So see here, you have the like a RBC. Okay, the distances between them, it's around 7 to 10 micrometer, and the wavelength of this sound is around 0.2 and 1 millimeter. So when the width is bigger than when the width is less than the wavelength, scattering will happen. Okay, and this is the example of that one. See, it's just like a scattering will happen here. All right. Okay, what do you have? Refraction or refraction. Refraction occurs when the sound signal is deflected from the straight path and angle of reflection is away from the transducer. A tissue boundary with the differences in the velocity with no perpendicular it will be happen. So when the sound is coming and you have here is not like a straight tissue, it's just like we have something bending. Okay, so the angle is not the same. That means when the sound coming, it will be reflected and go far away from the sound. That means reflection occurs when it causes a change in the direction of the beam of ultrasound at boundary between two medium, and finally can result in ultrasound double image artifacts. So the artifacts will happen when you have a refraction. The attenuation, when the sound will be travel and it will be reducing the energy of the sound. Ultrasound attenuation, a loss of aqueous energy with the distance travel, is caused achieved by the scattering and the tissue observation of the incidence beam. And this is important. Just like what that means? That means when you have ultrasound, okay, and you want to go to have a deep details to the deep, you will send ultrasound with the high wavelength. See, with the high wavelength and low frequency. When you want to make this is the skin, this is your skin, and this is your body. Okay, if you want to make the image for something here, what type of ultrasound you will send? You will say I will send ultrasound with the high wavelength, like this one. If you have this is your skin and you want to make something here to make the image for something close to the skin, what you will send? You will send ultrasound with the low wavelength, or let's say high frequency. Okay, just like ultrasound attenuation expressed by decibel is expressed the proportional to the frequency. A frequency is increase. Okay, so when the frequency increase, you are increasing the frequency, the depth will be decreased. When you are decrease the frequency, the depth will be what? Will be decreased. And in the exam, maybe I will bring you this one. Explain this statement. The depth of the perturbation become less as the frequency increase. The ability to observe the deep lining structure is forfeited, or it will be impossible, or it cannot be happen. You will say when the frequency will be increased, we cannot go deeply inside your body. If you want to make deeply inside our body, you need to have a wavelength. We need to have ultrasound have less what? Have less a frequency or higher wavelength. The summary: sound is a mechanical energy that transmits by creation, compression, and reflection packages in the medium. The overall effect of the medium compressibility and density on the sound will be summarized by the statement that density increase, the velocity of sound will be increased. The major interaction of ultrasound is a reflection. This is the major one. A differences in the aqueous abundance causes some portion of the sound will be reflected as interferences. If they have big differences, all this high reflection sound will be. If you have low, and so on. Observation is the only process whereby the sound energy is dissipated in the medium. The observation is of ultrasound beam is related to the beam frequency, velocity, and the relaxation time of the medium. And this is the end of this part. Thank you very much.